Hello, my name is Nadja Tao, and I would like to speak a little bit about what I've read so far in this book, Where Mathematics Comes From. Beautiful cover. I've only read up to here, but I think I've got quite a bit of material already to talk about, and I don't want to make a really long video that tells you everything um, you need to know about the book, and so you don't read the book. I don't want that to happen. So I'm going to just start. I've taken notes. So if you see me looking down, it's because I'm reading my notes. Um, so this book is about the cognitive science behind mathematics. And it starts off asserting that all of our ideas are shaped and grounded by our day to day sensory experiences. And that's usually what cognitive science teaches. Would that also apply to mathematics? The book is exploring that. They are saying, being the authors George Lakoff and Raphael E. Nunez, they're saying that yes, even abstract reasoning pulls from metaphors that are grounded out of daily bodily experience. So in the introduction, the authors make it clear that they're convinced that Platonism, the idea that math transcends human bodies and minds, is faith-based. And they think math is based in the human mind, or at least that's all we can really know for sure. They say that most mathematical thought is unconscious, and they say that mathematical thought arises out of layers and layers of metaphors. But math's dependence on metaphors also leaves a lot of room for confusion. And the example they gave was, is 0 a point on a line? Or is it the empty set? Or is it both? Or is it just a number and neither a point nor a set? Each answer comes from a different choice of metaphor, and each choice of metaphor determines the subject. So, all of this has implications for teaching math. The authors believe that because these metaphors are based on common experiences, mathematical ideas can be understood using everyday terms. So, part 1 of the book is about arithmetic. And chapter 1 establishes that very basic mathematical abilities are present practically from birth. And animals also have basic mathematical abilities. They talk about how memorizing math, like memorizing multiplication tables or memorizing the answers to equations, takes place in one part of the brain, while actual calculation takes part in another part of the brain, and algebra takes place in a third part of the brain. The part of the brain where arithmetic calculation takes place has associations between all of the senses. It's called, the part of the brain that does this is called the inferior parietal cortex. The way they tested the babies and animals for counting abilities was kind of interesting. They measure whether or not the babies are bored. So they show 2 dots to the babies until the babies stop paying attention. And then they show the babies 3 dots. And the babies are fascinated by this change. Something else they do is show 2 puppets. And then they put up a screen. And then they secretly take away one. The baby can't see someone taking away one of the puppets. Then the screen is lifted and the baby is shocked to see that there's only one puppet left when there was 2. If the baby can see someone take away the puppets, though, the baby's not surprised. With rats, they have them count the number of times they have to press lever A before they can press lever B and get a food reward. And chimpanzees can even do arithmetic with numeric symbols after training for a couple of years. So chapter 2 is still talking about arithmetic, and this chapter talks about 4 conceptual mechanisms that are central to understanding mathematics: spatial and visual, motor control, mapping a more primitive concept onto another, and mapping 2 complex concepts onto another. The spatial visual example has to do with concepts like in and out, boundaries, and it gives the example of one cup inside of another cup, or a book that's in contact with the desk. And the visual imagery part of the brain isn't just about sight. Blind people can do visual imagery experiments, and dreams activate this part of the brain, the visual spatial part of the brain, and we can see things inside of our minds. The motor control example has to do with readiness, starting a process, pausing, and checking for completion. And there's an intersection with visual schemas in moving trajectories, starting points, ending points, positions, and directions. The more primitive conceptual metaphors involve associating stuff like importance with size, like it's not a big deal, we can ignore it. Or difficulties being associated with burdens, like I've got a light load this semester. And the example they gave for blending more complex concepts together is the unit circle in trigonometry, where you map a circle with a radius of 1 onto a Cartesian plane. And chapters 3 and 4 mostly just outline the basic rules of arithmetic, like how a times b is the same as b times a, or a times 1 equals a. But the authors point out some other stuff, like how irrational numbers can exist because we blended the concept of numbers with physical length. So the square root of 2 shouldn't be real if we're just dealing with numbers, because it goes on forever. But the square root of 2 can exist if the numbers have a physical length. So a stick can be the length of the square root of 2. I thought that idea was pretty cool. Another section talked about how algebra is a way of generalizing when we don't know specific details. The example they gave is how we understand a sentence like, give the pizza boy a good tip. We don't know who specifically the pizza boy will be, but we can generalize about the pizza boy with that sentence. And I think one of the biggest problems today with work is that we're applying really simplistic math equations like this to manage very complex people. Anyway, another topic that caught my interest was the metaphorical associations with some numbers like 0 and 1. 0 is a metaphor for destruction or absence, and 1 is a symbol for unity or wholeness and individuality. And the other topic that caught my interest was how they explained that a lot of math comes about because we're seeking closure. So one example they gave is because 3 minus 5 isn't a natural number, we created negative numbers. And then moving on to part 2. Part 2 is about algebra, logic, and sets. And I think the most interesting thing I took away from part 2 is the story of how Boolean truth tables came about. George Boole was trying to force Venn diagrams and sets to follow arithmetic rules. Sorry, I'm trying to understand my notes. I think this part of the book had Venn diagrams, and the Venn diagrams represented sets. So I don't know if I made that clear or not. So he's trying to force these Venn diagram sets to follow arithmetic rules, but 1 and 0 didn't fit. So he made truth tables as a kind of exception to the rules that would work for sets. And I'd like to share a great quote from the book from part 2. It's talking about the comparison between ordered pairs and the von Neumann construction of natural numbers of sets, when it says it's common. Now let me start over. It is common for different concepts to have the same metaphorical source. For example, you're warm can have at least 2 metaphorical meanings, and the meanings were you're warm as in you're so personable, you're so friendly, you're so caring, or you're warm as in your experience of temperature is high. So then we get to part 3, infinity. I don't know, for some reason I didn't find the part about infinity to be as interesting as I had thought I would. But the earlier chapters kind of talk a lot about infinity. So yeah, I just kind of started to lose a little bit of interest after part 3. But the book suggests that the embodied concept of infinity comes from breathing and moving. So for as long as we're alive, we breathe, and for as long as we're alive, we move. The book says our aspectual system, which is a system that picks up on how a verbal event extends over time. The aspectual system senses the concept of infinity through breathing. Now, I think that's very possible. I mean, sounds pretty good to me, but my instinct is also telling me something else. I think we embody the idea of eternity through pain and suffering. Because when you're suffering, it seems to last forever. But yeah, I'm going to stop here because I'm starting a pretty intense certification program, and I kind of worry that this video won't see the light of day if I don't do it now while the book is kind of fresh in my mind. But yeah, this gives you a taste of the book. I loved thinking about these concepts, and if you don't mind reading some denser material and you like math, I think you will enjoy this book too. So let me show it to you one more time. Where mathematics comes from, how the embodied mind brings mathematics into being.